Hi everyone, welcome to the session. In this session, we'll solve some more problems related to equilibrium of concurrent force system related to three spheres with some different condition. We'll go through the problem. In this problem, we need to determine the reaction at contact points of spheres, that is nothing but contact surfaces of spheres A, B, C as shown in the figure. It's given that weight of A and B sphere as 4 kilonewton and weight of C sphere as 6 kilonewton and diameter of A and B sphere as 500 mm, and it's a diameter given, and diameter of sphere number C is nothing but 800 mm. So we need to determine the reaction at contact surfaces for this particular problem, and also they mentioned the different contact surfaces. If you go to A, we have three contact surfaces P, O and K. If you go to B sphere, we have N and M, two contact surfaces, as well as L, one more contact surfaces, overall three contact surfaces. And if you go for C, we have K and L, two contact surfaces. Okay, now the first step, we need to draw the free body diagram of each spheres separately one by one. Okay, next, coming to the free body diagram of C. Before going to free body diagram, you have small calculations, or small, you need to calculate angles. uh, uh, Sphere number C is in contact with the sphere number A and B at K and L. So the free body diagram will be, no doubt there is a self weight of your sphere C is nothing but 6 kilonewton, and it should be acts vertically downward direction, and reaction at this particular surface K, and reaction on C by A, so it is RK, and reaction between C and B, reaction on C by B, and it's nothing but reaction at L on C. So we have overall three forces, 1, 2, 3. Out of 3, 2 are reactions and one is nothing but self weight. To calculate internal angles, included angles, you need to calculate, because there are only three forces. We can apply the Lami's theorem. For that, we need to calculate this internal angle theta 1 and theta 2, whatever I have shown here, theta 1 and theta 2. And one more dimension is given, center to center distance between center of A and center of sphere B as 600 mm. And in the problem it is mentioned A and B are lines are joined. It doesn't anything, it is not a wire or a string, is nothing like that. Just to mention this particular 600 mm, they indicated by this particular line. And 600 mm is already given, and diameter of A and diameter of B is same, dA equal to dB equal to 500 mm, but diameter of C is 800 mm. And sphere number A is resting on a inclined vertical surface with 75 degree to horizontal axis, and sphere number B is resting on inclined vertical surface which makes 65 degree with respect to horizontal, and C is resting on A and B. So I will form a triangle in such a way that joining center of A, center of C and center of B, it will be the form a triangle. From C I will drop a perpendicular which meets as D. Now if you see, ACD is a right angle triangle, again CDB is one more right angle triangle. Here if I drop a perpendicular from C which meets at D on the line AB, it should equally cut the line AB into equal halves, that is AD should be equal to DB, because these two are spheres, which are circular in shape, even though they are resting at a vertical wall with the different inclinations. So now we need to calculate this theta 1 and this theta 2, that is I represented here theta 1 and theta 2, and we know this is overall distance is 600 mm. So AD is nothing but 300 mm, and again DB is nothing but 300 mm. And to calculate AC, diameter of A is given as 500 mm, so radius will be 250 mm, and diameter of C is given as 800 mm, so radius will be half of the diameter 400 mm. So if I join center of A and center of C, AC distance will be 250 mm plus 400 mm, it will be 650 mm. And same thing will be there here also. Again, if I join center of B and center of C, it will be again same 650 mm, because the diameter of A and diameter of B are same as 500 mm. So if I calculate theta 1, again theta 1 will be equal to theta 2. Here theta 3 will be equal to theta 4. To calculate theta 1, I will use sin theta 1 equal to, I need to calculate this theta 1 in the triangle ACD. Sin theta 1, which is equal to 300 mm, that is nothing but opposite side divided by hypotenuse. 300 divided by 650. So it theta 1 works out to be 27.49 degree, which is equal to theta 2. Again, if you calculate theta 2, we'll get the same angle. So now theta 1, theta 2 I represented in this particular free body diagram. The remaining angle will be 360 minus 27.49 minus 27.49. It works out to me 305.02 degrees. Okay, free body diagram of sphere number C is completed, where I can use or apply the Lami's theorem. Coming to the free body diagram of sphere number A and sphere number B. Now I am going to draw the free body diagram of A. Here sphere number A is in contact with the three surfaces and self weight. No doubt self weight acts vertically downward direction. Self weight is nothing but 4 kilonewton for sphere number A. Sphere number A self weight is 4 kilonewton, that I represented, and I have sphere number A is in contact with the horizontal surface at O. So reaction on A by the horizontal surface at A, and reaction is always perpendicular to the surface, so it is RO. And one more reaction here at sphere number A and inclined wall, which makes an angle 75 degree with respect to horizontal. So if it is 75, this should also be 75 degree, as we already derived using the right angle triangles. If it is 75 degree, this will be again 75 degree. So RP, we got reaction on A by the surface at P, reaction on A by the surface at O, and one more is pending, reaction on A by the sphere C at K. So RK is the direction. So here we need to calculate theta 3. This theta 3 we need to calculate. Theta 3 is nothing but in this particular triangle, we got theta 1. This is nothing but 90 degree. So theta 3 is nothing but 180 minus 90 is 90. 90 minus 27.49. It will be 62.51 degree. 62.51 degree. Same angle will be there for theta 3 will be equal to theta 4. So theta 4 will be also same angle will be there. Coming to the sphere B, if you draw the free body diagram, it will be we have self weight 4 kilonewton acts vertically downward direction, and reaction on B by the surface at N, it acts vertically upward direction, and reaction on the B by the surface at M is nothing but RM, and again this will be 65 degree. This here it is 65 degree, it should also be 65 degree. Reaction on B by the C, and which makes an angle theta 4. Already we found theta 4 as 62.51 degrees. So for center A or sphere A and sphere B, I cannot apply Lami's theorem because I have overall 4 forces, 1, 2, 3, 4. Here 1, 2, 3, 4 forces. I cannot apply the Lami's theorem. I need to go the conditions of equilibrium, that is f of x equal to 0, f of y equal to 0. Now coming to the sphere number C, where I can apply the Lami's theorem, we have 3 forces. 6 divided by sine 305.02 equal to minus RK, because the force is coming towards C, minus RK divided by sine 27.49, which is equal to minus RL divided by sine 27.49. It works out to be RK equal to 3.382 kilonewton and RL equal to 3.382 kilonewton. RK should be equal to RL because these two angles are same. Now we got RK and RL. Coming to the sphere number A, we need to solve sphere number A, where there are 4 forces, 1, 2, 3, 4 forces. I cannot apply Lami's theorem. I need to apply the equations of equilibrium. For that, if I will apply f of x equal to 0, so it will be rk cos 62.51 plus rp sin 75, which is equal to 0, and we already came to know what is rk from sphere number C. Substitute the value, only rp will be the unknown. Rp works out to be 1.616 kilonewton. And applying on more equations of equilibrium, summation of f of y equal to 0, it will be minus rk acts vertically downward direction sin 62.51 degree plus rp cos 75 plus RO plus RO acts vertically upward minus 4, and here RK is already known to us, and again RP is known to us from previous part f of x equation. It is 1.616 and only unknown will be RO, and RO works out to be 6.582 kilonewton. And coming to the last, that is free body diagram of B. Again, there are 4 forces I should apply. I cannot apply Lami's theorem. I should apply the f of x equal to 0, f of y equal to 0 equations of equilibrium. By applying this, I will apply summation f of x equal to 0. It will be RL cos 62.51 minus Rm minus Rm sin 65 equal to 0. And I know the value of RL from sphere number C. So apply the value of your RL. It works out to be 3.382 kilonewton and minus Rm sin 65, which is equal to 0, and only one unknown which is nothing but Rm. Calculate Rm, and Rm works out to be 1.722 kilonewton. Now coming to second condition, summation of f of y equal to 0, it works out to be minus RL minus RL vertical downward direction sin 62.51 plus Rn minus 4 downward direction plus 1.722 cos, that is nothing but Rm is nothing but vertically upward, so it will be plus 1.722 cos 65, which is equal to 0, and only one unknown is nothing but your Rn, and Rn works out to be 6.273 kilonewton. This is all about this particular problem. Now take this as a assignment problem where A and in this particular problem is given we need to find the reaction at the contact surfaces as well as A and B are connected by a string or a wire where tension force is going to develop, and it's nothing but A and B are resting on a horizontal surface, and radius of all the three RA, RB, RC is equal to 200 mm, which means all three spheres are identical. Out of those, A and B are resting on this particular horizontal surface. So two reactions here, it will be, we will be having two reactions, and the sphere C is resting on A and B. We need to find a reaction at all the contact surfaces and tension developed at this particular string AB.